Alright, here are some practice problems on linear regression. If these look a little weird, and especially this table down here, it's because all of these were made with ChatGPT, since you can't really get them from the College Board, because it's not directly tested on. It's still a really important skill to know and a shortcut to use, so we're gonna get some practice in. A linear model estimates the revenue of a company from 2010 to 2020. In these real-world application problems, your initial year or your starting year, that's going to be x equals 0. And then since 2020 is 10 years from 2010, x would be equal to 10. The model estimates the revenue was 120 million in 2010, 200 million in 2015, and 280 million in 2020. To nearest whole number, what is the value of the estimated revenue in 2012? So this would be 2 years from 2010, x is equal to 2. Let's go ahead and start putting these values into our table. Our years will be our x values, and our revenue, or our millions, would be our y value. We have 120 million in 2010. 2010 is 0, and 120 million is just, I'm gonna just do 120, but imagine there's the word million right after it. Then we have 200 million in 2015. 2015 is 5 years from 2010, so x is equal to 5. And then 200 million. Once again, imagine there's a million right after that. All you have to do is stay consistent with it, you know what I'm saying? Anyways, there's a third point, but we don't need that third point since we only need 2 points for linear regression. y1 tilde mx1 plus b. Now we have our slope and our y-intercept. There's so many ways you could do this. First way you could do it like this, where you just go ahead and substitute it in. Y is equal to 16x plus 120. Then all you have to do is go to this gear icon right up here, click a table, and then you can find it in x equal to, it's 152 million. Another way you could do it is, of course, just not make the table and just replace this x with 2. Oh shoot, what happened? Alright, with 2. And then you get y equals 152. And a third way you could do it is, what you could do is you could put in f of x is equal to mx plus b. And now you can just do f of 2. You get 152. So that was just 3 different ways that you could do it. Whatever way works for you, whatever way is the fastest for you, you do that way. Let's move on to question number 2. A linear model estimates the number of students in a school district from 2005 to 2025. Once again, 2005 is going to be our year 0, so x equals 0. Let's see if I can write that in. Alright, well, you're not going to be able to see that, but yeah. The model estimates that there were 5,200 students in 2005, 6,100 students in 2015, and projects 7,000 students in 2025. To nearest whole number, what is the value of the estimated number of students in 2020? So, once again, our years will be our x values and our students will be our y value. In 2005, we had 5,200. 2005 is going to be year 0, and we had 5,200. 2015, that's year 5. Oh wait, no. I was saying the last question. 2015 is 10 years from 2005, so x is 10, I mean. And then they had 6,100 students. Once again, we have a third point, but I'm gonna just ignore that because we only need 2 points for linear regression. y1 tilde mx1 plus b, and we get our parameters. This time, I'm gonna just do the f of x thingy. So f of x is equal to mx plus b. And oh yeah, and this part right here, the second part, that's just the standard form. So we get a quadratic regression. You would put f of x is equal to x1 squared plus bx plus c. Anyways, now that we have that, they want the number of students in 2020. That's 15 years from 2005, so we're just going to do f of 15. And our answer would be, there would be 6,550 students in 2020. Question number 3, let's look at our question. A linear model estimates the height of a tree from 2000 to 2030. 2000 is going to be our year 0, and 2030 is 30 years from 2000, so x is equal to 30. The model estimates the tree was 10 feet tall in 2000, 25 feet tall in 2015, and projects the tree will be 40 feet tall in 2030. To the nearest whole number, what is the value of the estimated height of the tree in 2010? Once again, our years will be our x values and our height of the tree will be the y values. So let's start putting it in our table. 10 feet tall in 2000. 2000 is our year 0, so x equals 0. 10 feet tall, that's going to be our y. 25 feet tall in 2015. 2015 is 15 years from 2000, so x is equal to 15. And 25 feet tall. We do have a third point, but we can just ignore that third point because it's linear regression. Let's put in our regression equation, and we get our parameters. I'm going to do the f of x thing again. So f of x is equal to mx plus b. And then we can just do f of 2010. That's 10 years from 2000, so we'll be doing f of 10. And we get the answer is 20, so the tree would be 20 feet tall. Now another way you could actually do this, I just remembered this way, is that x equals 10, right? All we have to do is look at our graph, right over here, go to 10, and you can see that the y value is 20, so it would be 20 feet tall in year 10. There we go. Question number 4. A linear model estimates the distance a car travels from 1 p.m. to 4 p.m. So 1 p.m. is our initial value, it's our starting time. So this is actually gonna be x equals 0 to 4 p.m., which is 3 hours from 1 p.m. So x is equal to 3. Now I know that this is kind of trippy because it's like all one off, but stay with me, stay with me. The model estimates the car had traveled 50 miles by 1 p.m., 125 miles from 2:30 p.m., and 200 miles by 4 p.m. To the nearest whole number, what is the value of the estimated distance traveled by 3 p.m.? 3 p.m., that's 2 hours from 1 p.m. So x is equal to 2. Yeah, I know it's kind of weird, but just stay with me, stay with me. Your initial value, that's always going to be x equals 0. So our time or our hours, that's going to be our x values, and then our miles or distance traveled is going to be our y values. Now let's start putting that into the table. 50 miles by 1 p.m. 1 p.m. is x equals 0 and 50. Then we have 125 miles by 2:30 p.m. 2:30 p.m. is 1.5 hours from 1 p.m. So x is equal to 1.5 and 125 miles. Now if this whole 1.5 thingy kind of trips you up, we can just move to the next point, which is a lot easier because it's a whole number. So 4 p.m. that's x equals 3, and then we have 200 miles. It's honestly okay if you have this extra point, it doesn't matter. Let's move to our regression equation. y1 equals mx1 plus b. Then I'm going to do the f of x thingy. F of x equals mx plus b. Then we're going to do f of 2. Then we get the answer is 150 miles. So the car traveled 150 miles by 3 p.m. Question number 5. A linear model estimates the temperature of a cooling pie from the time it's taken out of the oven at minute 0 to minute 60. So thankfully this one actually starts at 0. So this one's obviously x equals 0, x equals 60. The model estimates the pie was 400 degrees at minute 0, 300 degrees at minute 20, and 200 degrees at minute 40. To the nearest whole number, what is the value of the estimated temperature at minute 30? This one's pretty easy. I mean, the x values are going to be the minutes, and the y values will be the temperature, and thankfully, it actually starts on minute 0. Let's start putting this into our table now. 400 degrees at minute 0, so 0, 400, and, let me underline that, and 300 degrees at minute 20. Minute 20, minute 20 and 300 degrees. We do have another point, but since it's linear regression, we don't need to worry about that. Let's put in our regression equation now, and we get that. This time around, I'm change things up. Y equals -5, and x would be minute 30 plus 400. So our answer would be 250 degrees. It would be 250 degrees Fahrenheit at minute 30. Question number 6. The table shows two values of m and their corresponding values n. So this is literally just x and y. The graph of the linear equation representing this relationship passes through the point p, 4. What is the value of p? So they do give you this table right here. I'm going to go ahead and put that in desmos. But if you really look at it, you can tell that it's just multiplying by 3. So there we go. Now we're trying to find this one point right here where the y value is 4. we just have to find the x value. And there's two ways, I think. There's probably more ways, but I know two ways you can do this. The first way is to just type in here y equals 4, and now we're just gonna see the point, and we would see the point is 1.3334. So our answer would be 4 over 3. Another way we could do it is just substitute 4 into the equation. So we know that y is equal to mx plus b, right? We already know what y is. Y is 4 equal to m. We know m is 3. We don't know x, plus b, which is 0. And then I'm gonna go ahead and turn these off, and you can see that it's just gonna put a line on the x value, which is 1.333. So 4 over 3. Now the problem is, if we look at our answer choices, none of these are actually 4 over 3. And the reason for this is because ChatGPT is kind of dookie, but the answer is 4 over 3. I actually just realized, but I've been thinking so much about desmos, I didn't even realize, like this equation right here, 4 equals 3x, we could just get x by itself by dividing by 3, so 4 over 3 is equal to x. But that requires you to write it out, and like no one likes writing it out, just put it in desmos. Question number 7. The table shows two values of a and the corresponding values of b, so just x and y again. The graph of the linear equation representing this relationship passes through the point 2, q. What is the value of q? So once again, we have the thingy, the table, so I'm gonna just plug these points in. Negative 1, 5, 3, 13, and y1 tilde mx1 plus b. Then we have our thingies here. And this time, they gave you the x value instead of the y value. Now if they give you the x value, that makes life even easier, because it's just gonna be like the first 5 questions we did where we just need to substitute it in. This time though, I'm gonna change things up. So they give you x, right? So we can just do x equals 2, and then we just look at the y value where they intersect, which is 11. So our answer would be D, which is 11. Now you could do the whole f of x thing, or you could make a table, or you could substitute it in. Whatever way you want to do it, there's like a million different ways to do it. Or you can even solve it by hand, but that's definitely the worst option. Never solve it by hand. That takes way too long. Especially for these types of questions. Some questions, maybe, but these, they're so easy. Just put it in desmos. Question number 8. The table shows two values of C and the corresponding values of D, X and Y. Yeah, these are all like copy and paste questions. They like change the numbers up. Well, yeah, I'm into ChatGPT. Okay, anyways, the graph of the linear equation representing this relationship has a y-intercept at 0, r. What is the value of r? Just like the rest, let's put this into a table real quick. And regression. Then we're trying to find the r. But if you remember, whenever the x is 0, that's really just finding the y-intercept. And we know right here that our y-intercept is negative 1. So our answer is negative 1. Or of course, you could do f of 0, or you could look at the graph, see where x is equal to 0, or you could substitute it in, y equals. I'm not doing all that, but yeah, whole bunch of different ways to do it. Question number 9. The table shows two values of e and the corresponding values of f. If the graph of the linear equation representing the relationship is shifted 3 units upward, at what point does it intersect the y-axis? So, just like the rest, let's put this in the table real quick. Negative 4, negative 2, 2, 4, y1 tilde mx1 plus b. Then we have our equation. And they're asking for when it intersects the y-axis, which is the y-intercept. So right here it says the y-intercept is 2, so our answer is B. Now I'm just kidding, because right here it says it's shifted 3 units upward, so we have to add 3 to it. So 2 plus 3 is 5, so our answer is D. We could do that, or you could just get this equation, y equals mx plus b, then you just add 3 again. Look at the y-intercept, that's 5, or just add 3. You know, like, yeah, I mean, there's so many ways to do it. But regardless of what you do it, the answer is 5, or 0, 5, because they want the whole point. Oh yeah, they asked for the point. Question number 10. In the xy plane, line K intersects the y-axis at point 0, negative 4. It passes through the point 3, negative 3. If the point 10W lies on line K, oh yo, what is it? Yo, ChatGPT be wildin', what? Okay, anyways, we do have 2 points right here, 0, 4 and 3, 3. So we can go ahead and put this into the thingy, into the table. What am I saying? 33. mx1 plus b. Oh shoot, what was happening? Oh. Plus b. There we go. And they want the y value at 0.10. So just like the rest, f of 10, whatever. Y equals, oh shoot, yeah, no. I'm gonna just do x equals 10. Wow, it's 19.333. Let's see what that's as a fraction. So I'm gonna just put a whole bunch of 3's because we know it's repeating. And the fraction is 58 over 3. So our answer is 58 over 3. Question number 11. In the xy plane, line K intersects the y-axis at the point 0, -2 and passes through the point 4, -6. If the point 8w lies on line K, what is the value of w? So we have 2 points, and we're trying to find the y value of this other point. Let's go ahead and put those 2 points into a table, and then regressionize that. Oh, that is not a word. Now we have that. I'm gonna just do f of x equals mx plus b. And now I'm gonna do f of 8. And we get our answer is 14. So w equals 14. Question number 12. In the xy plane, line intersects the y-axis at the point 0, 5 and passes through the point 1, 7. If the point 3w lies on line k, what's the value of w? Once again, 2 points. We're finding the y value. Oh, why did I do that? I meant to click this. 0, 5, 1, 7, y1, mx1 plus b, and then I'll just do f of 3. Oops, f of 3. Oh dang, I forgot to f of x. Oops. F of x equals mx plus b, and f of 3 is 11. So w equals 11. Question number 13. In the xy plane, line intersects the y-axis at the point 0, -3 and passes through the point 6, nice. If the point 12w lies on line k, what is the value of w? 2 points, find the y value. 0, -3, 6, 9, y1, mx1 plus b, f of x equals mx plus b, and then we're gonna do f of 12. Oops, f of 12, and we get that it's 21, so w equals 21. Question number 14. This is the last one of these set of questions, so I'm gonna try and speedrun it. In the xy plane, line k intersects y-axis at the point 0, 1 and passes through the point 5, 11. The point 15w lies on line k, what's the value of w? Okay, so we have 2 points, we have point 0, 1 and 5, 11. Let's go ahead and put that in the regression model. Yep. F of x is equal to mx plus b. F of 15, 31. Boom. W equals 31. Question number 10. Wait, 15. This is question number 15. I don't know why this says 10. Anyways, the table shows 2 values of g and the corresponding values of h. If the graph of the linear equation representing this relationship is reflected over the x-axis, what is the value of s in a point 1s that lies on the reflected line? So they do give us a table. I'm going to go ahead and put these points in. 0, 3. Then I'm also going to do the regression. F of x is equal to mx plus b. Now I'm going to go ahead and find the point 1s. So f of 1. And we get that it's 2. So on the original line, it's going to be 1, 2. Now, it's reflected over the x-axis. So all that means is we're going to swap the signs of the y value. So on the reflected line, it's going to be 1, comma, -2. So our answer is going to be -2. Right here. Question number 16. I don't know why this says 11. Yeah, for some reason it started back up at like 10, but yeah. This is number 16. The same economist models the demand Q for a different product as the linear function of its price P. So basically just X and Y. When the price was $25, the demand was 50,000 units. When the price increased to $30, the demand dropped to 45,000 units. According to the model, what would the demand be if the price was set to $35? So we're going to go ahead and make a table. Our price is going to be our X, and our demand will be our Y's. So here, our price is $25, and our demand is 50,000. And here, our price is 30, and our demand is 45,000. Now, we're gonna go ahead and do our regression, and then f of x is equal to mx plus b. Then they're asking what the demand would be if the price was $35, so we're gonna do f of 35. And we'll see the price would be 40,000, so our answer is B. Question number 17, ignore that. A car manufacturer's sales data shows that when the price of a particular model was $22,000, they sold 30,000 units. Later, they raised the price to $24,000 and sold 26,000 units. Assuming a linear demand model, how many units can they be expected to sell if they set the price at $21,000? Just like the last question, our dollars are going to be our x values and our units are going to be our y values. So let's put this in a table. $22,000 and 30,000 units, and then $24,000 and 26,000 units. Now let's do our regression. Y1 tilde mx1 plus b, and then f of x is equal to mx plus b, and they're asking for $21,000, so we're going to do f of 21,000. And we can see our answer would be 32,000, so they would sell 32,000 units, which is B. Question number 18, the very last one. Ignore this. A software company prices a new app based on a linear demand model. At a price of $9.99, the projected number of subscribers is 100,000. For every dollar increase in price, the company anticipates losing 5,000 potential subscribers. Based on this model, how many subscribers would they gain if they decrease the price by $2? So they do give us one point right here, which is $9.99 and 100,000 subscribers. You don't get the second point, but they literally just give you the slope or the rate of change. So dollar increase, you lose 5,000, which means if we decrease a dollar, we're gonna gain 5,000. So if they decrease by $2, they would gain whatever 5,000 times 2 is, which is just 10,000. So they would gain 10,000 subscribers. 10,000 plus 100,000 is just 110,000. I don't know why I'm writing this all out, but our answer is C. So as you can see in this case, it's going to be a lot faster to just solve it in your mind than put it in desmos. But since the whole point is linear regression, I'm going to put it in desmos too. So we do get our first point, which is $9.99 and 100,000 subscribers. They also say a dollar increase, we'd lose 5,000. So I'm going to change that to $10.99 as a second point, and I'm going to subtract 95,000. Well, I'm going to subtract 5,000 and get 95,000. Y1 equals mx1 plus b. F of x is equals to mx plus b. And they're asking how many subscribers they would gain if they decrease the price by $2. So we're actually not going to do f of negative 2. We're going to just do $9.99 minus $2, which is $7.99. And then we'll do f of $7.99, which is 110,000, the exact same thing. But I think you could tell that that took way longer than just doing it like this. Alright, I mean, you didn't even need to write out as I did. Everyone can do 2 times 5,000 in their head and add 10,000 to 100,000. Anyways, that was all of linear regression. That was a bunch of linear regression problems. You can see that it's so easy, dude. All you need to do is find your points, then put it in this table. And it's also super important that you remember what the regression formula is. But once you got those two, you're literally set. I mean, that's literally all you need to do. And then you do see that sometimes in some cases, it might be faster than not do linear regression. And you also know there's a bunch of different ways to get your answer other than using f of x, or just substituting it, or looking at it on the graph. No matter what way you do it, just do the way that's the easiest or the fastest for you. I will link the video to the quadratic regression in the description. I think I want to make them separate because I think this one has already gone pretty long. Anyways, I'll see ya.